Hi, my name is Arif Abdul Kareem, and I'm a solutions architect with Databricks supporting CMS. And today I want to talk about two topics that are gaining a ton of steam in the industry at large, but specifically at CMS. The first is the concept of a data mesh, and the second is the concept of a lake house. So I want to talk a little bit about what these two terms mean, their implementations, and then I want to talk about how they relate to one another and the benefits and really the relevance to CMS. But before we jump in, I actually just want to start with a quick introduction to Databricks for those who aren't already familiar with the company. So Databricks is the data and AI company. We're actually the inventors and the pioneers of this term lakehouse and of the paradigm overall, although it's been adopted widely by a number of different vendors throughout the industry now. We also are the only cloud native vendor to be named in both Gartner Magic Quadrants, both for database management systems, as well as for data science and machine learning platforms, which for us is a big deal because it really kind of highlights this vision of a lakehouse, which is the idea of bringing the best of both worlds, the data reliability and data management capabilities that you would typically look for in a data warehouse, while at the same time providing the flexibility and scalability for data science and machine learning that you would typically look to get out of a data lake. We're also the creators of a number of highly successful data projects, open source data projects, Delta Lake, Apache Spark, ML Flow, just to name a few. Over 3,000 employees across the globe and over 6,000 customers across the globe, including a number of public sector customers, as you can see the logos on the screen here, and specifically a number of federal customers. Okay, within CMS alone, we actually have 9 different footprints. And really the use cases for why Databricks is being used throughout CMS, it runs the gamut from collaborative data science, to running as the ETL engine for a number of programs, as well as some programs that are starting to adopt the full lakehouse vision, where Databricks is being used both as a data science and machine learning platform, as well as for data warehousing workloads. And then one more plug before I jump into the full presentation. I want to just bring up these two talks. I'll be kind of covering this idea of a data mesh and a lakehouse and how they relate in brief. But for those who are interested in going into more detail, are certainly welcome to reach out to me directly and schedule a deep dive. But I would also strongly recommend checking out the session from Zhamak Dehghani, who is essentially the creator of this concept of a data mesh. She's the one who introduced the term. And she gave a talk about this and how it relates to the Lakehouse at the Databricks hosted Data and AI Summit this year. I would also recommend a talk by Matej Zaharia, who is the creator of Apache Spark and one of the founders of Databricks. He also gave a talk on this subject, which I would strongly recommend checking out. Both of these are available online. Okay, so now let's level set by providing somewhat of a formal introduction to these two terms, data mesh and data lakehouse. So first, when we talk about a data mesh, I think the most important thing to highlight is that a data mesh is not a technology. It's actually an organizational model that is completely technology agnostic. And really its purpose is to ensure that you get value from data analytics at scale. Whereas when we look at the Databricks Lakehouse, it is a technology. It's a very specific collection of technologies to enable and deliver data, analytics, and AI at scale for all use cases. So think data science and machine learning use cases, as well as data warehousing use cases, ETL, data engineering use cases, streaming, batch, different types of data formats, so structured, unstructured, semi-structured. The idea of a lakehouse is to bring all of this together in a single platform. And this is done by combining the best elements of both a data lake and a data warehouse. Okay, now to answer the question, how does a data mesh and the Databricks Lakehouse relate to one another? We have to dive a little bit deeper into understanding exactly what the goals are of this organizational model called a data mesh. And I think we can do so by looking at the principles that were laid out when this term was introduced by Zhamak. And she laid out 4 key principles that relate to really the kind of the aspirations of a data mesh. The first being domain-oriented data ownership. And this is really the idea of providing data producers or domains, or in CMS, maybe what we would refer to as program offices, with autonomy to have ownership over their analytics and their workloads. The second principle she laid out was this idea of data as a product. And this really means that you're treating data with the quality and care, ensuring data quality that is kind of necessary for a product versus it being a byproduct of some system or some process. And then the third one I think is extremely important because it's kind of needed for you to be able to achieve one and two. And that's the idea of self-service infrastructure, having a self-service infrastructure platform, so that each domain, has the ability to be able to control the infrastructure that is responsible for building and executing their data product. And then finally, the last principle that she laid out is the principle of federated computational governance. And I would say that this is the mesh and data mesh, right? How do you have some sort of global, how do you create an ecosystem that adheres to global rules, so that each of these kind of autonomous domains are still adhering to some sort of centralized governance rule? Now, when we ask the question, how does this relate to a lake house? We can kind of see how the two map to one another. So first, when we look at domain-oriented data ownership, in the Databricks Lakehouse, this is really achieved through the workspace. And the workspace provides a place where each domain, each program office can have ownership over their data assets and their pipelines. And I'll show this in a little bit more detail shortly. Then when we look at data as a product, right, what's the map into the Lakehouse? And this is where the technology Delta comes in. Delta is really kind of the foundation of the Lakehouse. And it's also the foundation of this principle. In order to be able to ensure that you have reliable quality data, Delta Lake and the asset guarantees that come with it are extremely important, as well as additional tools and capabilities that come with the Databricks Lakehouse, like Delta Live Tables, which is a tool that we don't have time to go into detail, but certainly it makes this this idea of creating a data pipeline that produces high quality data as a product at the end. But also it's important to adhere to open standards, both for data sharing, which we'll touch on in a second, as well as just open data formats in general, in order to be able to achieve this data as a product concept, so that you can have consumers that are not only internal, but also external as well. And then when we look at self-service infrastructure, this is where orchestration tools within Databricks comes into play, and the ability to be able to auto scale, so that each domain, even if they're not necessarily on the infrastructure team, are provided with a way to be able to quickly provision the compute resources necessary for their workloads. Again, if they don't have the ability to be able to have some ownership over that, then it's difficult to have ownership over their data assets and pipelines. And then finally, when we look at federated computational governance, the heart of the data mesh, this is where the Databricks Unity Catalog comes into play. And this really is a way of being able to enforce centralized governance access controls, as well as to be able to provide global policy templates for data access and compute resources. Okay, now this is kind of a different view of this. This is really looking at what this looks like in action. And we have two different ways of looking at this. The first on the left is the Lakehouse view. And when we look at the Lakehouse, at the bottom layer, we have our scalable storage through the data lake, where you can store all types of data, structured, unstructured, semi-structured. And then sitting on top of that is Delta Lake, which is giving you that data reliability and performance on top of your data lake. And then the layer on top of that is the governance layer through Unity Catalog to govern data access and controls. And then finally, we have orchestration, automation, and optimized runtimes that sits on top of all of this, and is provided to each domain, each program, in the form of a workspace where they have access to compute resources. And they also have the ability to be able to carry out all of their data-related use cases, whether that's ETL, whether that's real-time apps through streaming, whether that's data warehousing, being able to do BI workloads, or data science and machine learning related workloads. So that's on the left. That's the Lakehouse view. When you look to the right, this is really the data mesh view, where we can see each domain, again, exists within a workspace. And then Unity Catalog is that governance layer, that federated computational governance layer that sits in between all of these workspaces. So this is really the view when we look within a single organization, right? And how do you kind of create a data mesh within an organization across domains? But what about when you want to extend further? You want to go outside to external organizations or even external technologies, because this view is very Databricks centric. So that's where delta sharing comes in. This is where you can now expand your data mesh to not only include a single program or a single organization, but to also start to include external consumers. So through delta sharing, you now have a mechanism to be able to provide governed access to external consumers. And this can take place within Databricks to Databricks workspaces, or even to external technologies. So you can see here, Power BI, Tableau, anything that is a service that runs Spark can act as a consumer for delta sharing, as well as anything that can run Python and Pandas can act as a service. You can also share across clouds, so from AWS to Google to Azure, or even on-prem. So now Delta really kind of rounds out this idea of a data mesh that not only extends within an organization, but it also goes and expands out to external organization. So this is the real macro view, kind of the zoomed out view. But what I also want to do is kind of take a zoomed in look and look at the kind of capabilities that exist within the domain. So if we're looking at, what are kind of the minimal capabilities that have to exist within a data domain to actually be able to provide some of these capabilities and live up to these principles that we laid out. The first is the ability to access the various different data sources, and then to be able to run those data sources through the domain-owned pipeline that curates that data and eventually publishes that data for consumption. And then also, what you get within Databricks is the ability to be able to consume that data once it's published, whether that's for data science, using the domain's choice of ML and AI tools, or if that's consuming it through a data warehouse with BI tools, either internal to Databricks or external. And then also, again, now you can go and take it a step further and start to use delta sharing to be able to publish that data as a product that is available to teams that are completely outside of the data domain and even outside of the organization, as we showed in that macro view. So I want to just kind of sum up this really brief, really kind of high level introduction to a data mesh and how it fits into the Lakehouse by talking about some of the benefits of adopting this data mesh and data lakehouse paradigm within CMS. And I think maybe one of the key benefits to highlight is the idea of distributed responsibility, starting to move away from a monolithic data platform with central processes and a central team that really acts as a bottleneck and prevents each domain, each program from being able to move at their pace, as well as prevents them from being able to ensure that their data meets the needs for their particular mission or their particular workload. And then connected to that is process acceleration. Once you start to distribute responsibility and remove that bottleneck, it now means that domains can move faster because they have full ownership over their process, over their workloads, and over their data. And then you also get improved data quality by adopting this principle of data as a product. So that data that is going to be shared within a domain, within an organization, and then to external consumers all meets a certain quality standard. And you're provided with the tools within Databricks to be able to ensure that quality in a less complex way, which actually brings me to the final benefit, and that's reduced complexity. I think this is something that is specific to data mesh, taking advantage of the capabilities that already lives within the data lakehouse. And it's one of the reasons why combining these two concepts, taking this organizational model and taking advantage of the technologies that exist within a lakehouse to enable this organizational model is a really good idea. Within a domain, you kind of reduce complexity by ensuring that teams have the ability to be able to carry out all of their different data use cases without having to stitch together a bunch of different tools and try to figure out how to integrate them and how they work together. And then you're also minimizing complexity when it comes to being able to enforce that centralized governance model, which is the key to the data mesh. This can be something that is extremely difficult, extremely tricky, extremely hard to be able to manage. And Unity Catalog and Delta Sharing simplify that a ton. And with that, I want to wrap up. I realized that this was a very brief introduction, a very brief talk, and we didn't go into a lot of the details. So I certainly would welcome, any direct reach out as a follow-up to this talk. If you would like to learn more about the specific details of how we would implement a data mesh on the Data Lakehouse, you can either reach out to myself directly, again, Arif Abdul Karim. You can reach out to me on the email shown on the screen, or you can reach out to my counterpart on the business side at CMS, Bob Kilper, also his email shown on the screen. Thank you.